In this video, we are going to see how we can create our own crypto token using MetaMask wallet. Obviously, we are not going to create a real crypto token. We are going to create a dummy crypto token which doesn't have any real value. However, it will demonstrate how such crypto tokens can be created even if you want to create a real one. I've already created a MetaMask wallet, and this is the MetaMask wallet. Now, since we are going to create a dummy crypto token, we can connect to a test Ethereum network, which can provide dummy or test ethers which do not have real value. However, such ethers are required to pay the transaction fees. We are connected to the Sepolia test network. I have already collected some free Sepolia test ethers, which I'm going to use for the purpose of paying the transaction fees for creating the crypto token as well as transferring the crypto token between two accounts. I've already created two accounts here, account 1 and account 2. And after I create the crypto token, I'm going to transfer some crypto token from account 1 to account 2. Note that each account is identified by a unique public address, which is given over here. It starts with 0x3f for account 1, and for account 2, it starts with 0x124. We'll try to remember these first few digits so that we can identify the transactions that are happening from one account to another account. Now, in order to create the crypto token, we need to create a smart contract in Solidity. We will use an integrated development environment called Remix, where you can go by typing this remix.ethereum.org, where we are going to create the smart contract. We are going to create two smart contracts, one smart contract for the creation of the token and the other smart contract for creating an interface for the transaction of the token, including creating the first supply of the token. The two smart contracts are already available in my GitHub library. So you can access this by typing this github.com/tanu22/blockchain. These are the two contracts we are going to use, EIP20 and EIP20 interface. EIP20 will create the crypto tokens, and EIP20 interface will create the interface for generating the first set of tokens. Let us go to EIP20. We'll copy this, we'll make some minor changes, and we'll compile the contract and deploy them. Similarly, we'll do the same for EIP20 interface. We'll go to the Ethereum. We'll create a folder for our new token. Let's call our new token as my new token. We'll create a folder, my new token. And under this new folder, I'm going to create a Solidity contract. And the Solidity contract also will be named as my new token. So this is a Solidity contract, which you can see is .sol file. We'll copy the code from EIP20. Ensure that you copy it as is. And we'll make some minor changes. We'll change the name of the contract to the one that we have given in the name, is my new token. Similarly, we'll change this in the function as well. My new token. First contract is done. We'll now make the second contract, which is the EIP20 interface. We are not going to change the name of this. We'll keep it as it is. Ensure that name exactly the same because this contract is called into the other contract, my new token contract. So if there is a small change in name, then it will not be able to call and recognize and call the contract. You need to be careful about the naming, including the cases. EIP20 interface. Make sure you type the cases correctly. Copy this. We don't need to make any changes in this contract. So we'll compile these two. First compile. So this is the place to compile. The compilation is done right. You can see the green tick. Go to the other one. It will build some artifacts. We did not bother about the artifacts right now. The other one, the one which actually creates the points, will compile this one. That's got compiled. It is giving one warning, which we can ignore at this point of time. We are now going to deploy this contract into the Sepolia testnet. For that, we have to go over here and we will deploy on the MetaMask, using the MetaMask into the Sepolia network. So you must select this injected provider MetaMask, not others. Okay. And this is the contract that we want to deploy because this is the contract that will generate the Bitcoin. So do not deploy the other contract, the IP20 interface, deploy this contract. And for deploying, I need to provide the initial information. For example, I need to provide what is the initial amount of tokens that will be there in the circulation. This particular token has a finite supply, so we need to provide that. This is a dummy token, so I'm giving a small number, 2000. As you know, in a real token, there can be a large number. For example, for Bitcoin, the initial amount is, the amount in circulation is 21 million. The token name, my new token, we'll use decimal unit 0. Now, one thing you need to be careful about that when, suppose you give a decimal unit 2, then essentially what it means, it is going to deploy 20 coins. That means it will take 20.00. Okay. So sometimes you make a mistake that you assume that when the decimal unit is 2, it is deploying 2000.00. Actually, that's not the case. It will make 220.00. Similarly, if you have decimal plus 4, it will deploy only 0.2. And the token symbol is my new token, MNT. Now, when I do the transact, it is going to connect to my MetaMask wallet. It will ask against which account I want to do the transaction. This first transaction will be a creation of a contract that will hold the token. The contract address will become the identity of the token. Of course, we have the token symbol, etc., but these are more for identity by the user, but the actual identity will be the contract address. In order to do this transaction, which is a creation of the contract, you need to pay a fee because we are using the Sepolia test network. We'll pay the fee in dummy Ether. However, we need to pay a fee. That's why you need to ensure the account which is deploying the contract must have some dummy Ether in balance. In our case, it is Sepolia Ether. So we'll do the transact. You'll open up the MetaMask. If it is connected, if it is not connected, it will ask you for the connection. Now, account 1 was already connected, so it is selecting account 1. Account 1 has Ether. We have seen that, so there's no problem. And this is the fee that you have to pay though it is dummy ether. We'll just confirm. Once we confirm, the transaction will be queued and this block is generated, which means the transaction has been successful. In other words, our coin has been created and it is there in the test SQL. Now, how do we see the coin? For that, we have to go for wallet. Let us go to our wallet. Now, note that right now, all the 2000 coins are with account 1 because account 1 has created the contract and account 1 is in possession of all the 2000 coins. Where do I see the coins for account 1? Go to assets. Right now, the account 1 has 2 assets recorded. One is a Sequoia Ether. The other one is maybe another coin like the one that we have generated, which is BBC. But we don't see our coin. In order to see our coin, we have to import the token. But before you import the token, you'll ask for the contract address, which is the identity of the coin. Where do I get the contract address? In order to get the contract address, we'll go to the Sequoia and we will see that the transaction in the ether scan. Okay. So the transaction in the ether scan will carry the fees that has been generated. So let us see the transaction in the Sequoia Ether scan, and that will give us the address of the contract which has been created for the new coin. So go over here, view account in Explorer. Now you will see the transaction that has been created just now. If you go to and you can see here it says contract creation. That means I created a contract which has generated the new token. So go over here, you will see the contract address. So the Ether, the new coin has been created against this contract address. This is the identity of the new token that has been generated. We need to copy this address. We go back here. And now we need to import the token and we have to get the contract address of it. Now, when you give the contract address, automatically the token symbol will appear over it. Do not write the token symbol. If the token symbol does not automatically appear, it means your contract address is incorrect. You add the custom token. Now you can see already that is correctly identified. 2000 MNTs has been generated and it is now lying with account 1 because account 1 has initiated this particular token. Import the token. Now account 1 has a new asset. So if you go to the asset list of account 1, you'll see the new asset over here. Okay. This new asset will have its own transaction record, which can be seen over here. At this point of time, this new asset has no transactions because it has been generated from almost nowhere and is lying with account one. But as account one starts transferring this asset to other accounts, these transactions will get recorded over here. So let us now transfer, let's say, a part of this new token to account two. Now, in order to transfer assets between accounts, you need the address of the account. This is the address of account one, and the address of account two is this. So if you are transferring the new token to your friend's account, you need to know the account of your friend. It is a public data. It is like a bank account, just like you transfer money from one bank account to another bank account, you need the account number. So here also you need the account address. So let's say account one intends to transfer 10 units of or 20 units of my new token to account two. What will account one do? Go over here and account one will now send. Now, when account one says send, it has the option to give the account address over here, the address that we saw just now. In case account one wants to send to another account, it can give the address. Now, here, account one is transferring to account two. Now, both these accounts belong to the same wallet. One wallet can have many accounts. Now, when both the accounts belong to the same wallet, you don't need to copy paste the address. You can do it, but that is not required because you can say transfer between my accounts. It will automatically take the address. It is like saying transfer between two accounts in the same bank. Okay, so there you don't need to give certain details like IFSC code, etc. So it's the same thing like that. It's easier to transfer, but you could have also given the address. So here I'm transferring between the two accounts, the same wallet. So I can just say transfer between my account and I can say account two, transfer to account two. Now you can see it has already taken the address of account two. I did not have to manually enter. And I intend to transfer 20 MNTs to account. Now, whenever transaction happens, some fees have to be paid. Who will pay the fee? The sender will pay the fee, and this is the amount of fee that the sender will pay. So if I say next, the transaction should be executed on payment of this fee by account one. So let's say next. So this is the amount of fees that will have to be paid by account one. May again take some time for the transaction to get committed. The transaction seems to have got committed. So now account one should be left with 1980 MNTs and account two should have 20 MNTs. So let's go to asset and you see that account one has 1980 MNTs. If I want to see the actual transaction that has happened, I can go over here, view the asset, the transaction asset explorer, and now you see a new transaction has been generated where 20 MNTs has been transferred from account one. We know the address of account one starts with 0x3f to account two. We know the address of account two 0x12. Okay. Now let us see whether account two has received 20 or not. Let us go to account two. Now, account two will not be able to see the asset as long as account 2 does not import the asset. So account 2 has to import the asset that account 2 has received. For importing, account 2 will need the contract of the new token. We had copied the contract previously. Otherwise, account 2 needs to know the contract. Now, contract of the new token is a public data. It should be available to any user. So account 2 knows that contract address, copies this. You see that it is showing that account 2 has received 20 amenities. And now if account 2 wants to see the transaction in its own Explorer, account 2 will see that 0x3f has transferred 20 to 0x124, which is account 2's public address. Now, there is one more transaction that has happened, which is the fees which account 1 has paid. Where will account 1 see this? Account 1 will see this under Sepolia asset, because the fees were paid in Sepolia. The fees were not paid in this. And fees were paid by account 1, not by account 2. So to switch to account 1, go to Sepolia and view the assets. Now you see that this, so previously there was a contract creation. Now this must be the one where the fees were paid by 0x3. Okay. Now there is no actual fee that was paid in terms of Ether, but there's some dummy transactions that were a fee that was paid to dummy Ether. Okay. There's no actual transfer of Ether that has happened. So I hope this gives you an idea about how you can create your own token and how you can transfer tokens between different accounts. You can also understand that in this entire process, no central agency like a bank was involved. This is the reason why we say cryptocurrency using blockchain decentralizes the central authority that controls such fiat currencies.